If you remember the programming video from last year, we did a simple board game called Senet. And when I picked that game, I had said at the beginning that I wanted to pick a game that didn't have too many rules attached to it, so we didn't get lost creating the rules, and we were focusing more on writing the game itself and exercising our knowledge of C. Well, since then, somebody's asked me, what other types of games, what other types of board games could I write in C, and what would that look like? And so I thought I would do a video this week around how you might program a chessboard. Now, this isn't going to involve any of the movement of the pieces or the game rules or things like that. This is really just how would you create a chessboard in C. So let's take a look at writing that simple chessboard. So over here, I've got my environment, and we're just going to write a simple program here. And I don't have anything to start with, so go ahead and use our Fed editor, which is what I like to use for writing code on FreeDOS. We'll just call this one chess.c. So to get started, I'm going to do of course, my standard includes standard IO. And I'm also going to eventually put some stuff on the screen, and I'm going to use the graphics mode, or rather the text graphics mode. So we'll use the graph.h. We'll include graph.h. Now, before we get much further, we really should think about what the board is going to look like. So let me put a little comment here that actually think about what that board is going to look like. There are probably two different ways you could create a board in C. So this is a chessboard. If you remember, chessboard is an 8x8 grid. And so one thing I could do is I could create a list of 8 entries, 1, 2, 3, 4, 5, 6, 7, 8. And so I could create an array of 8 entries, just an array of pointers, and then each one of those has elements in it. So it has 0, 1, 2, 3, 4, 5, 6, 7 on every row. And so basically that's a standard 2-dimensional array. And on the surface, that's actually a pretty easy way to do it, because it basically gives me in this case a y and an x coordinate, and so now I've got my 64 squares, and that's not a bad way to do it. Other way you could do it though is say, look, 8 squares horizontally, 8 squares vertically. That's going to give me a grid of 64 squares. They're just going to be arranged 8 by 8. So that's an 8 by 8 grid. And so that's what I'm going to do here. I'm going to create an 8 by 8 grid as an array. It's going to be a single array. So it's a single dimensional array. And we're going to do some math to always make sure that we end up with a row and a column. Now, why am I doing it that way as opposed to doing it with that 2 by 2 array? Well, this way I only need to grab memory once. Rather than having a separate process that needs to go through and grab those 64 bytes of memory 8 different times, just divide it up into 8 different segments. This way I'm just grabbing one segment at once. It's not a very big array, and so grabbing memory probably either way probably doesn't matter that much. But here I just have to grab memory just the one time, just doing a 64 byte array. And so that's why I'm choosing to do that with a single array rather than 2 different arrays in my system. Now, let's also talk about how I'm going to store data for each of the pieces. So let's think about the pieces that we have on the board. I'm going to want to create a list here of the different types of pieces that can be on my board. Let's not forget that 0, we'll start with 0, is going to be an empty square, right? Because we're going to have a lot of those on the board. And then piece number 1 might be let's say a pawn. We're going to have a lot of those. Piece number 2 would be a knight. 3 would be a bishop. Wow, I'm kind of going all over the board here in terms of what's what, but that's not normally, I guess, the order I would go, but I guess so we're going to continue with that. So 4 would be, what else do I have here? I've got a rook on the board. I've got of course, a queen. And then, of course, the ultimate piece is the king. That's the one you're trying to capture. Let's think about how we would represent that in binary. So here I'm just going to say, so here's our binary values. And our binary values are going to be binary, remember, kind of looks like 8, 4, 2, 1, and some stuff off to the left, right, 1632. But I only need a couple of these binary bits to really capture all of my pieces. 0 through 6 doesn't really require a lot. Obviously, if it's an empty square, it's going to be all zeros. Pawn at 1 is going to be 0, 0, 0, 1. The number 2 is going to be represented by 0, 0, 1, 0. A 3 is represented by 0, 0, 1, 1. 4, remembering our binary, 0, 1, 0, 0. And a number 5 is a 0, 1, 0, 1. And then the number 6 is 0, 1, 1, 0, right? So that's my binary representation of all of the pieces that I could store on the board, including, by the way, the empty square. Now, I also want to track whether or not these pieces can be black or white, right? Those are the different opposing sides, black and white. So that's just a bit. And so I'm going to use the binary 8-bit to store whether or not this is a black piece, because I only really need 3 bits to capture 1 or 0 through 6. And so I'm going to use that next bit, the 4th bit, that represents the number 8, as indicating whether or not something is a black piece or a white piece. So let's look at then what my defines would look like based on that. So I'm going to say, based on that, based on color, I'm going to define white as being 0, and that's all zeros. That's specifically a binary 0, 0, 0, 0. And we'll define black as 1. And remember, that's going to be, I'm sorry, that's not 1, it's an 8. Binary of 8, and that looks like a binary of 1, 0, 0, 0. Right? Now let's look at the pieces. So I can have empty as 0. Define the pawn as 1. Define the knight as 2. Let's add some spaces here to make it look nice. I'm going to define the bishop as 3. Define the rook as 4. And by the way, since I got those out of order, if you wanted to make this a different order, you could very easily do that by just changing the defines. There's nothing magic about the order I've happened to have picked in terms of the 1 through 6. Define the queen as 5, and then define the king, let's spell that correctly, as 6. I should probably also create something that's going to mask off the piece. So if I wanted to be able to compare something for the piece versus the color, I don't know if I'm going to use that in this demo, but if you'd need to do that, you'd say, okay, here's a mask for the piece on the board, and so that's going to be we'll just call this a piece mask, and we'll just call it as 7, right? Because what is 7? 7 is binary of 0, 1, 1, 1. And so if I needed to do something to say, I only want to grab the piece for something, I could grab whatever cell entry that I have in the array, do a binary AND with piece, which is 7, binary 0, 1, 1, 1, and that would get me just the value of the piece. So that's going to be 0 through 6, because those are the pieces I've defined. So with those definitions in place, I can now start to write my program. Now I'm going to write a very simple demonstration program here. We'll do a main program. And we're going to do an integer array of the board. and the board's going to have 64 elements in it. Now, I'd probably do better to malloc this array, but this is a simple demo program, so let's not get lost in the malloc. Let's just stick this on the as a static array, and so that's going to be an 8x8 board, and an 8x8 board, of course, has 64 squares in it. And then once I've done that, I can call a function that's going to initialize the board, and we should probably give it the array. And then once we've initialized the board, we can now display the board. There's the array. And then once we're done with that, we can return back the operating system, and that's the end of our program. So this is a very simple demonstration program. Let's think about, how do we initialize the board in that case? So how do we initialize this board? Well, we want to put all the pieces on. This is a function we're going to call once at the beginning of the game just to set the board up. We're not going to call this function all the time. We're only going to initialize the board the one time at the beginning. Now, we could probably have put this code in the main function itself, but I'm going to make this a separate function on its own. So we're going to create a function that doesn't return any value, so it's called a void function called init board. And then our array, remember that's an integer array called board. And then what's inside that? So I want to be able to track the row and the column. So we'll call it integer variables called row and col. And now let's go ahead and start by, now I could at first sort of zero the entire array, just put empties into everything, but I'm going to end up putting pieces on top anyway. So I'm just saying one way you could do this is to actually just make the entire board 0. Your compiler, by the way, might do that for you. Be very careful about assuming how your compiler is going to initialize arrays. So your compiler might happen to make that array 0 when you define the array. Not all compilers do. The C compiler standard says that you'll get whatever happens to be in memory at that address at the time that you define that array. So same for any variable. So don't assume that it's 0. I always find it safest to, if I need it to be a certain value, even if it's going to be 0, give it that certain value. So we're going to go ahead and now create an initialization here. Now I could, I suppose, have initialized this with 64 entries. That's going to be really hard to read. With the curly braces, I did the curly braces to initialize an array. But here I'm just going to use a couple of loops here to kind of define something. Actually, to define the player 2 pieces, remember that's at the top of the screen here. These are the player 2. We can actually just define the back row because they're all going to be different anyway. We can define that with a just a series of 8 statements. I suppose I could do this sort of a weird loop that kind of goes in from the edges, but you know what? For simplicity, let's just say board at position 7 times 8 is going to be a rook that is black. And at board position, now I'm doing this math. So what I'm basically saying is the row is going to be row 7 because it goes 0 through 7. And there's 8 elements on a row. And so that's why I'm doing that multiplication times 8. Well, the next one over, when you think about it, is going to be 7 times 8 plus 1. Now, this is all just a number. I could just put in the number, but this is making it a little bit easier for us to see that this is how my math is working out. Because as I think about, and this is going to be, by the way, a knight, and that's going to be black. So when you think about it, what I'm doing is I'm creating a board that looks like this. On the back row, this is going to be row 7. 1, 2, 3, 4, 5, 6, 7. And then the next row from the top is going to be row 6. 1, 2, 3, 4, 5, 6, 7. Oops, these are 8. And then it's going to be row 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. So this is what my square is going to look like. It's an 8 by 8 grid. And the way that I'm going to do it is every position up here is going to be, well, this is the 7th row. And so it's going to be, this position right here is going to be 7 times 8. And so this will be 7 times 8 plus 1. You think about it this way, this is going to be 6 times 8, 5 times 8, oops, 4 times 8, 3 times 8, 2 times 8, 1 times 8, and this is basically 0 times 8 plus 0, 0 times 8 plus 1, right? 0 times 8 plus 2. So that's how they're all going out. 0 plus 8 plus 7, right? That's what these are all going to be. And then the next one would be 1 times 8 plus 0, right? So that's how they're all marching up in terms of their progression. So that's where I'm doing all this math down here. So I'm basically placing these pieces according to some math. And yeah, I could just write in what these numbers are, but I'm trying to show you how the numbers are progressing. And I could, you know, one reason you could just put in the numbers is that way you're not asking the compiler to do any work for you, but the compiler is going to optimize this anyway, and these math won't actually show up in the code. It's not actually going to figure out what the math is. When you run these program statements, it's going to have done that in the compiler statement itself. Continuing to do this row on the back, it's going to be 7 times 8 plus 2 is going to be the bishop, and that's going to be black as well. And then the board position at the 7th row plus 3 is going to be a queen, black. Board position at 7 times 8 plus 4 is going to be the king. I think I got that in the right direction. Black, and then the board at 7 times 8 plus 5 should be, now we're going back to a bishop. 7 times 8 plus 6 is going to be now another knight, and that's black. And then the final one in the back row is going to be 7 times 8 plus 7, and that should be another rook. And I could line these up with some spaces and things, but for right now, I think that's, you're kind of seeing where it's going. Now, what's the pawn row? I could do the same thing with these 8 different program statements to do that, but it's just, I can do a for loop on that one. So let's do a for each of the column positions starting at 0, as long as the column is less than 8. So that'll go from 0 through 7, and then at the end of each iteration, we're going to iterate column. We're going to add 1 to it. And then we're going to say at that board position of, remember, it's the 6th row, which is starting at 6 times 8, plus whatever the column is going to be a pawn that is black. And then that's the end of my loop. So it's really just one statement. And then we do the same thing for the player 1 rows. So at the bottom of the screen, we've got the player 1 rows. And we could do the pawns right away. So we could do for column equals 0, column is less than 8, column plus plus. And then we could say at board position, I suppose I could have put this in this other loop up here if I really wanted to reduce the loops, but I'm doing this once. Let's just show off how we're doing it. I could say at position board, it's really 1 times 8, so 8 plus the column position is going to be a pawn that is, in this case, white. And then below that, we've got the back row. So at board, remember this is the 0th row, and so this is going to be board 0 is going to be a rook that is white. At board position 1, we have a knight that's white. And at board position 2, we have a bishop that's white. And at board position 3, we have a queen, and that one is white. It's been a while since I played chess. I think I'm getting this right. I think it's queen on the left, then the king. And then board position 4, which is really the 5th square over, is going to be the king. And then the at board position 5, the other side of that should be another bishop. That's white. And then board position 6 is another knight. That's white. And at board position 7, so the last on this row is going to be another rook, and that is white. So now I've initialized the board. Oops, except the middle board. I haven't done the middle rows yet. Let's just put it up here between the player 1 and player 2. Let's go ahead now and empty the middle rows. So we'll do empty rows, and then for the row starting at 2, and then as long as the row is less than 6. What am I doing this right here? So this was row 1, and this was row 0, and up here we've got row 6 and row 7. So actually here I want to do this as being less than less than row 6, and then I want to add to the row. And then between there, I want to do now for each of the column positions, for column equals 0, and then the column being less than 8, and then the column plus. And then at that square, at position, remember that's going to be the row times 8. And then we're going to add to that the column, and that's going to be an empty square. And so now we've initialized our board. And if we wanted to, we should, well, not want to, we actually have to write another function called display board. Let's do that one as a real quick demo here, and then we'll go back and make it a little bit fancier looking. So let's create a new function here. It's not returning anything. We'll just call it display board. So it's a void function, display board, and then there's our array that we're passing it. And again, we're going to iterate through that as the row and the column. So to print that out, let's start at the back row. So let's do 4. This is the top row, rather. So 4 row is 7, and the row has to be greater than or equal to 0, because that's the first row, the bottom row on the screen, and then row minus every time we're done with that loop. And then inside there, we're going to print out the pieces by column. So we're going to do for column equals 0. And then the column is less than 8, and then the column plus. And then in between there, we're going to print a piece. And so in this case, let's create a function called print piece. at the board position of the row times 8 plus the column. That's the element of the array that we want to print out on the screen. And then when we're done with that, let's do this as a plain sort of thing here. So we'll just do a put care of a new line. We'll make this, fancy with colors and things in a minute, but let's go ahead and make a function up here called void function of print piece. And in this case, it's going to be an integer piece value. I'm abbreviating because I hate typing long variable names. I probably should call that piece, but right now let's call it PC, sort of abbreviating. Now I'm going to create an array that I'm going to use inside this function here called pieces. That'll be a string, and we'll call it, let's just say we have an empty square, and then what was the order I had up above? If you remember up above, the very, very top, we had pawn, knight, bishop, rook, queen, and king. Go back down. I'm going to put them in that order. So it was a pawn, knight, bishop, rook, queen, king. And then let's go ahead and put in our display. So let's go ahead and just we'll do a put care. It's a very simple test here of the pieces array at whatever is the value at that position. So that should be piece. I think I got that right. And so that should display a character that is showing off the value of that piece. I think that's what I'm doing here. So I've got an integer coming in. That should be the piece that's there. And then that'll be a value from 0 to 7, and that should print out what I've got here. So that should work. Oh, and of course I probably should, let's make sure remember I got black and I got white in there. So I probably should want to do a binary AND. Remember with that mask that we created? So there was the binary mask of piece, and we're going to binary AND that into the piece. Because if you remember the pieces, they've got a, just to remind ourselves here, right? The pieces have been assigned things like rook with, black or white attached to them. And so white was 0, but black had a value attached to it. And so what I'm trying to do here with this mask is the piece was going to be like that. And then the color was going to be right there. So that was actually black. And so by doing this binary AND with piece, I should be pulling that off. And so let's compile it. Before I do that, I want to double check to make sure I got something right. And now that I think about that, yeah, okay. So I got my black is correct up there. That's white and that's black. So that's what I want. Let's go ahead and compile this and see if we get a simple version of a board printed out. So we'll do a file and then save quit. Let's go ahead and use our Watcom compiler and linker on chess.c. And I don't see any errors, so let's go ahead and now run chess. And so now we've printed out, oh, and my board is actually kind of weird. I have some stuff in the middle. What did I do wrong? It looks like the middle of my board is not defined right, so that means I've done something wrong. So let's do chess.c. So somewhere in there when I was defining the middle of my board, I've got, yeah, board is empty, and empty should be 0 as I did up here. There's empty. I'm not sure what I did wrong there. If I did that right, let's make sure I got that right. So from row 2 to row 6, let's make sure that that's, I'm sorry, it's row 2 to row 5. And that means it's going to be these middle rows. And that's correct. I want it to be row 2 to row 5. And they're going to be, they should be zeroed out to be completely nothing. And that's, I thought, what I've got right here. So at board position, row times 8 plus the column, I'm setting it to, oh, well, that's my problem right here. That instead of less than 0, I really need to have less than 8. So that was a typo. Let's go ahead and compile that. Save, WCL, chess.c, right? So, yep, we really truly did get random positions or random values there. And now let's go ahead and run chess. So now that, yeah, there we go. Now we got a blank board in the middle. So we've just now debugged our program live. And so that is how you debug a program. Not what I intended to do, but there you are. Now let's go ahead and add some color to this program. So we'll make it, we can see what's a black piece and what's a white piece. Let's go ahead and now add that into fed chess.c. And that'll be inside the print piece function. So that was down here. So instead of this put char, I want to use do an out text function from the graph.h. So I'm not going to do, so actually that needs to be a string. So up here, I need to have a temporary string. So I'm going to just have a variable, just a temporary variable called display. It's really going to be 2 characters wrong because it's going to be, I could actually say 2, but it's going to be initialized here with some sort of a value that we're going to fill in. And remember, the null that terminates that it counts, but you don't see it. So even though we've only put in 1 character, there's an invisible null character back here, and so that's a 2-character array. But I've just let the compiler figure that out by using the empty square brackets. And so instead of doing a put char, now I actually want to do a I want to change the value of that question mark display at that position 0 is going to be what? That's going to be just what I've got on the next row. So it's going to be pieces, and then piece masked together with PC. So now I can get rid of that, because now instead of that, I want to add, let's get rid of this too. Instead of that, now I'm going to be able to do an out text function with display. So that's going to, if you remember, out text is going to always display the contents of a string, which is why I had to make the temporary string here. And all we're doing is we're just putting out basically a single character at a time. This is not the most efficient way to do it, but this is not a bad way to do the demo. So we're going to do it this way here. So we're going to probably should change the color depending on what piece this is. Oh, and by the way, down here, we probably should, before I forget about it, instead of doing a put char, we should do an out text down here as well. I didn't want to forget that later. Now, back up here, we probably should change the color based on the piece. And so let's go ahead and say, let's set the color. So if this piece is black, so a function that we're about to write here called is black for whatever that piece is. Remember, because that piece is carrying a value that indicates if it's a bit, the bit that says if it's black or not. And so we're going to say if it's black, then we're going to set the text color to, oh, what should we set? We'll set it to 14. That's a very obvious color. That should be bright yellow. And if it's not black, remember it has to be white. So we're going to say else, and then we're going to set that text color to be, let's just make it 7. So that's just going to be like standard white. And then I'm displaying the piece. So we'll have a little comment here, display the piece. Now, probably a better way to do this, if I'm going to actually do this as a chess game that I would have on a DOS screen, is I would have each one of these squares be some sort of a region on the display. And so that's just a math problem to figure out how many rows you want to have, and then to make them look more or less rectangular, because remember a single character is taller than it is wide. You just want to sort of add some extra columns to each one of those, and then sort of make it look nice by setting the right width for the height of each square. But here it's just a quick little demo to show how you would display these pieces. The rest of it is just sort of making it look nice. So now we've got that function done. Let's go ahead now and write another function up here about that is black. And so this is an integer function called is black. And that's, again, that integer piece. And that is just the single value of, we're going to pop off that black bit. And so we're going to do a piece and black. Yeah, I could have done that down here. I suppose I didn't have to do all, as a separate function, but at least it reads better. We're actually, as a programmer, we're saying, yeah, if that piece is black, then set it to yellow, rather than saying if piece binary and with black. You kind of have to put a comment to remind yourself about it. This is a little bit in terms of readability. This should be a little bit better for readability, but be aware, if you're trying to optimize this, you might just put in that instead of if is black piece, you just do if piece binary with black. And I think that's probably all I need to do. Now, I'm not showing like the alternating colors for the background of each one of the squares. That's something else you'd probably want to do in an actual chess game. But for here, we're just going to do a simple demonstration of is it a black piece? And if it is, we're going to show that in a bright yellow color. And if it's not a black piece, then we're going to show it in a standard sort of white color. So let's go ahead and now compile this. We'll do File, Save, and Exit. And we're going to do watcom compiler and linker WCL on chess.c. And I don't see any errors, so let's go ahead and run chess. And now there you go. You've got a chessboard that's been printed to the screen. You're showing the empty squares, and the ones that are black at the top of the screen are being shown in this bright yellow, and the ones that aren't black are being shown in that standard white. Now, as I said, there's a lot more that you could do to this to actually make it look like a real chessboard and use the whole screen. You could do some stuff around clearing the screen and, as I said, making those different squares on the screen and sort of figuring out how to represent each one of these pieces on the board. Or you could even flip it over into graphics mode, which actually might look a little bit better anyway. And then you could use drawing characters to the screen and making little shapes for the different pieces, the pawn, the knight, the king, things like that, or create some sprites and put those up there instead of just drawing with drawing functions. But just be able to show what it looks like to make a chess game. This was the question somebody asked me, how would you make a chess board game? And that's probably how I would start it out. Again, there's lots of different ways you can write any kind of program, especially in C. Again, one other way that you could do this is with a two-dimensional array, but here I've just done it as one, just so I'm only grabbing the memory the one time. But C has lots of different ways. With any kind of programming, you have lots of different ways to solve problems, and by knowing some programming, you can make the game or the program that you want that acts the way that you want it to run. And that's the great thing about programming. So that's it for this week about programming. If you have any other things you'd like me to cover, put that in the comments below. Before I go, I want to thank everybody who supports me on Patreon. You really do make this channel happen. So thank you very much for your support. Some of you are sponsoring me at a higher level, and I wanted to thank you especially here for that. Visit our website at freedos.org, join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. And don't forget to like and subscribe. Thank you.